Okay, so let's see what we found with our modeled listeners. Again, we're going to be looking at matching child behavior around 3, 4, and 5, and adult behavior, looking at a baseline model that has accurate representations and accurate deployment, as well as inaccurate variants. So either ones that have only inaccurate representations, ones that have only inaccurate deployment, and ones that have both inaccurate representation and inaccurate deployment. And we're going to be looking at these Bayesian information criterion BIC scores, right, which are going to range between 0 and infinity, where closer to 0 is better. So the lower numbers are the ones that are the best match to the empirical data we have. So let's start with kids. What do we see? So FYI, turns out that BIC scores within 2 are considered equivalent, so both of these are actually going to be the best among these 4 options. What does that mean? Well, it means that 3-year-old pronoun interpretation behavior is best captured by children having either inaccurate representations or inaccurate deployment, but not both, right? That one's not nearly as good, right? So one of these is inaccurate. And perhaps notably is that all 3 inaccurate variants are far better than the baseline that has accurate representations and accurate deployment. So clearly something is inaccurate, and we're just a little unsure about which it is, but it's not both. Now the same pattern holds for 4-year-olds and 5-year-olds too. We see the same thing, right? So either inaccurate representations or inaccurate deployment, not both, not accurate everything. If we look at adults, it turns out that adult pronoun interpretation behavior is best captured by the inaccurate representations modeled listener, right? That one we're pretty clear on. And so, like the child models, right, all of our inaccurate variants are far better than the baseline, but the winner is the one with inaccurate representations. It's better than the other 2 inaccurate options. Okay, so what does this mean? Well, it means that both child and adult pronoun interpretation behavior in this context are captured by modeled listeners that are inaccurate in some way. And the interesting thing is, how are they inaccurate, right? But perhaps a nice message here is that becoming adult-like doesn't mean becoming accurate. No. So let's look at this. What does it mean? It means learning to become inaccurate in adult-like ways, right? That's what it means to sort of undergo appropriate development. And so we know that adults, in this case we think from our modeled listener, that adults are inaccurately representing the available information. So we can look at the sigma contrast values to see how the inaccurate representations are inaccurate. Are they too smooth or too sharp? Like, what way is it, right? And we can do the same thing for the child listeners that use inaccurate representations. How do those sigma values compare, right? Are they too smooth or too sharp? How does that compare to what the adults are doing? Now, we know that adults, at least on the basis of these results, accurately deploy their representations. So development, in the case certainly of the inaccurate deployment child, is how much less than 1 are these beta use values, right? Are they kind of just a little less, or are like they really not using information and looking rather different from adults? So let's look. Again, our sigma contrast values range between 0 and 4, and our betas between 0 and 1, how often you're using the information. And let's start by remembering that for an inaccurate representation center that has accurate deployment, it means beta is always 1. You're always paying attention to all the information, right? And that's our best fitting for our adult and for one of our child listeners. Now, interestingly, if we go over here and look at the sigma values, one sort of similarity really between child and adult modeled behavior here is that adults and children are completely smoothing away information about the prior. It's 0, right? No change is needed to become adult-like. You just don't pay attention to the prior. You don't care. Interestingly, this is functionally the same, actually, as never using this information as if the betas were 0, right? You can either smooth it away completely or never use it, and so in this case, with inaccurate representations, they're smoothing it away completely. But again, the main point here is that you don't need to change a thing to become adult-like. You just don't pay attention to the prior. So that's kind of cool. But now let's look at what's going on with this sigma. And what we notice here is there's a qualitative similarity, is that both adults and children are smoothing away information about the form, the connective, and the agreement morphology, right? All the sigmas are less than 1, effectively turning down the contrast. They're doing the same thing, right? So there's a qualitative similarity, but there's some quantitative differences. It seems like children are smoothing more overall, with a highest value of 0.28, but most of them are kind of 0.11 or below, while the adults are in this 0.25 to 0.33 range, right? And you might wonder yourself, well, these values are all kind of low. How much difference, does that actually make? And we can just sort of see that with an example. So if we have 0.75 versus 0.25 is the true probability, a sigma of 0.33 is going to squish that down to 0.59 versus 0.41. A sigma of 0.28, which is actually one of the adult values and the highest child value, squishes that to 0.58 versus 0.42. So, there's not a lot of difference there, but you start to see differences when your sigmas get lower. So a sigma of 0.11, we'll squish this down to 0.53 versus 0.47, and of course for a sigma of 0.02 we're almost down to 50-50, right? So it starts to matter when you get much closer to zero. So the takeaway here is that though both adults and children may smooth away information, they're turning down the contrast, which is similar qualitatively, children may need to learn to smooth away less, right? They're going to turn up the contrast for the form, the connective, and the agreement morphology, although again, with the connective at range 5, they're almost there. And perhaps sort of also relevant is children may need to learn to smooth away the same amount, right? So 0.02 is a lot different from 0.28, right? Versus the adults are a little bit more evenly smoothed, as it were, across these three information types. Now, that's one possibility. But the other one, right, the other one that was equally compatible with our child data was that children could have accurate representations but inaccurate deployment. This would be a serious qualitative difference from adults who would have inaccurate representations but accurate deployment. So if they have accurate representations, that's sigma of 1, you're using all your information just as it is. And what you're doing different is deploying it less, right? You're not using it all the time in the moment. And our inaccurate deployment for our child model varies across the information types, though all are used less than 50%. So you're really not using it very much. You're using the connective and the morphology varying amounts, right? But the prior over antecedents and the form are completely ignored, right? And that's actually rather adult-like, right? Because you're basically smoothing away all information in the representation with a sigma of 0, and a beta of 0 means you never use it, right? So you're kind of accomplishing the same thing. So that's actually a qualitative similarity, even though there's this rather large qualitative difference across what's going on in terms of inaccurate deployment versus inaccurate representations. But, the main takeaway is that to become adult-like, children would need to switch to using most of their representations accurately all the time, right? And that's something that they would not be doing, right, if this is the model that's really going on. And they're going to have to learn to smooth away information for the form, the connective, and the agreement morphology.